probability that a call to a randomly chosen telephone number will reach a live person is 0.3. Suppose 10 such calls are made. What is the probability that one of them reaches a live person? So this is a binomial distribution. Considering the properties of a binomial distribution, there are n trials, n in this case are 10. There are independent. The probability of success from each trial is independent from another trial. Also, there are only two outcomes: reach a live person or otherwise. The probability P, success of reaching a live person, is given 0.3, which therefore implies failure. Probability of failure is 1 minus 0.3, which is 0.7. So now then, what is the probability of reaching exactly one person? So what you're looking for is probability x being equals to 1. This is n combination 1 multiplied by the probability of success 0.3 raised to power 1, and then probability of failure 0.7 raised to power n minus 1. This is 10 minus 1. So therefore this is 10 combination 1 multiplied by 0.3 multiplied by 0.7 raised to power 9, which is approximately 0.0403. So finally 10 combination 1 is 10. Multiplied by 0.3 multiplied by 0.0403, and eventually the probability of reaching exactly one person will be 0.1209. So the other case we have, what is the probability of reaching at least one of them, at least one live person? In this case, at least one means x is greater or equals to 1, and this will commonly probability of reaching 1, 2, all the way to probability of reaching 10 persons. So if you compute each of these probability and then sum them, you will get probability of at least 1. However, there is another approach. The probability of reaching 1, at least 1, is equivalent to 1 minus the probability of not reaching any live person. So p x equals to 0 will be equals to 10 combination 0 multiplied by 0.3 raised to power 0, 0.7 raised to power 10 minus 0, which is simply 10. So 10 combination 0 is 1, 0.3 raised to power 0 is 1, so this is 0.7 raised to power 10. Answer here will be 0.0282. So that is the probability of not reaching any of the persons. However, our interest was finding the probability of reaching one or the above probability, and eventually we find it's a 0.972 probability of 0.972 of reaching at least one live person. So here now we have the probability of reaching 3 or 7, or is addition. So what you're looking for is probability of reaching exactly 3 or the probability of reaching 7. So compute each of the case independently. Equals to 3 with 10 combination 3 multiplied by probability of reaching this will be 0.3 raised to power 3, 0.7 raised to power 10 minus 3. So once more, plug the numbers in our calculators. And this is 0.2667. On the other hand, the probability of reaching exactly 7 with 10 combination 7, 0.3 raised to power 7, and then 0.7 raised to power 10 minus 7, which is 3. And this will be, which is 0.009. Therefore, probability of 3 or 7 will be the sum of these two, 0.267 plus 0.009, and the resulting probability is 0.276. So lastly, we have will not reach 9 people. Probability, please note here the interest is not, will not reach 9. So there are two approaches when you come to handling such. One here is we have to note that the probability of interest is not reached. So P, probability of success here, is the event of interest is not reaching is 0.7, and Q, failure, this case, this is 0.3. So therefore, probability of x being equals to 9 will be equals to 10 combination 9 multiplied by probability of success now here is 0.7, and this case is raised to power 9, and then probability of failure 0.3 raised to 10 minus 9. Alright, then we have 10 combination 10 multiplied by 0.7 raised to power 9, which is 0.04, and then multiply by 0.3 raised to power 1, which is also 0.3. And the probability here is 0.1 to 1 approximately. So that is one way we could do this, but again we could also flip this over. The probability of not reaching 9 is equivalent to the probability of reaching 1. Note that the probability of not reaching 9 is equivalent to that. If you do not reach 9, it means you only reached one person. So you could also compute the probability of x of reaching 1. And earlier on, we had computed the probability of reaching exactly one person, and it was there about 0.12. So this was 0.1209, which is the same as that. So those are the two ways of finding the probability using binomial.